Hey guys, welcome to my channel Java Treasure Tech. Today's topic is Spring Boot REST API. We are going to learn everything about API today. The most important concept in software development, APIs, application programming interface. Let's keep it super simple. Think of an API like a waiter in a restaurant. You, as a user or a front-end application, don't go directly into the kitchen, right? Instead, you tell the waiter what you want. The waiter takes the request to the kitchen, gets it prepared, and brings the response back to you. That waiter is exactly what an API does. Now you might wonder, why do we even need an API? Why can't we just directly connect to the database? Good question, but bad idea. If you connect directly to the database, anyone can access sensitive data, modify records, or even delete everything. There is no control, no validation, no security, right? Imagine customers walking directly into the kitchen and cooking their own food. Total chaos, right? That's why API exists. We can see here that they provide security by making sure only authorized user can access your data. You can put the logic for the authentication, authorization. You can even control traffic spikes, and you can also put the logic for the rate limiting. You can add the logic for the SQL injection. They apply business logic like validating inputs or enforcing rules. They also control what data is sent back. So sensitive information like passwords or salaries is never exposed. Another important benefit is flexibility. API allows us to transform data, combine multiple sources, and send only what the front end actually needs. And finally, API makes systems scalable and maintainable. You can change your database or backend logic without breaking the front end because everything goes through the API layer. So, to summarize, API is the middle layer that handles communication, security, business logic, and data transformation between front end and backend. Without API, modern applications simply cannot function safely or efficiently. Now, we are going to build a complete Spring Boot REST API from the scratch, step by step, and I will explain every single concept clearly. Even if you are just starting out, it will all make sense to you. So today we are going to cover these many points. What is Maven and how does the M2 folder work? How does dependencies are managed using POM.xml? What Lombok is and why it saves you hundreds of lines of boilerplate code. Jackson ObjectMapper, how Java objects become JSON automatically. The difference between an entity and a DTO. This is very important. Java and ORM, how Java talks to the database without writing SQL. Application.properties, the config file that wires everything together. And finally, a fully working user CRUD API, create, read, update, delete. So now what is Maven? Think of a Maven as your project's personal assistant. Normally, if you want to use a library, say a library to connect to a database, you would have to manually download the jar file, put it in your project folder, and configure everything yourself. That's messy and error prone. Maven does all of this automatically. You just tell it what you need in a file called POM.xml, and Maven goes to the internet, downloads the library, and wires it into your project. So this is our POM.xml file. POM, full form of POM is Project Object Model. This is the heart of a Maven project. So here you can see that as a parent, I have added Spring Boot Startup Parent to inject some common libraries which are used to build up Spring Boot API. You can see here the Java version I have mentioned 25 and the other dependencies I have added. To understand the POM, group ID is like your company's package name. Artifact ID is your project name, and the version is, the version. Each dependency block is like saying Maven that, hey, go download this library for me. You don't need to specify URL. Maven already knows where to find it. But in any case, if you want to change that URL, the depot URL from where the Maven is downloading all these dependencies from the internet, then you need to update your setting.xml. Setting.xml would be having all the authentication, authorization related details mentioned. Now let's see the M2 folder. So after downloading all of these folders, where Maven is putting these dependencies. So this is the place. You can see here .m2. So when Maven downloads a dependency for the first time, it saves it in your computer in a folder name .m2, which sits in your home directory. You can see here. So the next time you build any project that needs the same library, Maven doesn't download it again. It reads it from M2. This is your local repository. You can see here inside M2 there is a repository folder and all of your dependencies have been added here. Each dependency gets its own folder, organized by group ID, artifact ID, and version. Very neat and clean. Now you can also see here the setting.xml path. which has all your authentication and authorization related details. Now let me talk about the Lombok here. This one is a game changer. Let me explain the problem first. In Java, whenever you create a class with some fields, you have to manually write lots of boilerplate code like getters, setters for every fields, constructor, and couple of string methods like toString equals and hash code methods, right? For a class with just a 5 fields, you might end up writing 60 to 80 lines of code that you don't care about. Lombok solves this. You add one annotation, and Lombok automatically generates all of that code at compile time. You never see, but it's there. Let me show you this user DTO. So you can see that here I have 3 fields: ID, username, and email. And I have used Lombok annotation, setter, and getter. If I don't use Lombok, then this is how my DTOs will look like. I will have to manually write all the setter and getters along with the constructors. No argument constructor and all argument constructors too, right? So now, as I've added this annotation, I don't need to write all of these. Okay, neat and clean. Now let's talk about the another dependency, Jackson. What is Jackson? When your API receives a request with a JSON body or sends back a response in a JSON, who is doing the conversion? Who is turning Java objects into JSON and back? For that, Jackson library is available, specifically class called ObjectMapper. Now, entity versus DTO. This is one of the most important concepts in backend development and one that beginners often skip. So, entity is a database mirror. Entity is tightly coupled with your database table. It is a Java class that maps directly to database table. It's your database representation in Java. This entity annotation tells JPA, which we will explain in the next segment, that this class is database table. Each field becomes a column, and ID marks the primary key. Generated value means the database auto increments it. And the DTO full form is data transfer object, is a simple plain Java class used to transfer data between layers, between the client and your API, or between your service and your controller layer. DTOs are your API's contract with the outside world. You control exactly what goes in and what comes out. So generally, when we're fetching a data from the database, we will fetch it in the form of entity, and then using the object mappers, we convert those entity into DTOs, and then we propagate DTOs further. We do not send entities further because those are having a security concerns. Hence, whenever you want to share the data between different layers, you pass it on using your DTOs and not entity. We can see here we have created user mapper, and you can see that here I'm using Jackson libraries for the conversion. We are using object mapper, and here you can see in the method to DTO we are passing the entity, and it is converting the entity into DTO class. By the same way, if we pass on the DTO, it converts it back to the entity. This is how it works. Okay. Now let's understand workflow of API. When you hit the API from your Postman client, it goes through different layers. The first one is your controller. It holds metadata of request and response. Do not write any business logic here. I repeat, do not write any of your business logic here. Now the next one is service layer. Here is the place where you put all your business logic or your validation related code, your DTO to entity and entity to DTO conversion. All those logic you can put it here. Now your service layer will connect to your ORM, your DAO, data access object, or your repository here, and those will be connecting to a DB. Now once the DB sends the response back to repository or your ORM, those response will be sent back to your service layer. Your service layer will work on it, and it will generate the proper format, send it back to your controller, and now your controller will send it back to Postman client. Let's start with the controller layer. You can see here that I've used REST controller annotation. REST controller is specialized annotation introduced in Spring 4.0 to simplify the creation of RESTful web services. It is a combination of controller and response body annotation, which automatically, the response body annotation automatically serializes its return value into JSON or XML. Now the second one you can see here is request mapping. These one is prefix of your API. All your API will get started with this prefix. Tag annotation is used to mention some metadata. Now you can see here that I have injected one dependency of a service class. You can also see that I haven't used auto-where annotation here because I have used a constructor injection here. So basically whenever you instantiate object of your this class, it automatically creates instance of this class and maps it from here. Now this is your real API. This is a very simple API where I'm just fetching all the data from database which are related to users. You can see I've used get mapping here because I'm not going to modify any data here. Let me click on this and you can see the request mapping mentioned here is request method get. Right? These are some metadata for your API. These are optional. The important part is this, your return type of your API. So response entity we use to mention the response type. Basically, if everything goes well, then we are going to return the status okay. Okay returns the status code 200. If user list is empty, then we are going to send HTTP status no content. And if, like as I mentioned, if everything is fine, then with the okay, we are going to return the user list. Now, this is the place from where your API is getting created. You can see here that I created an API. Basically, this API is fetching all the data from database which are related to users, returning it back to the client. This is the path of your API which will get appended to your request mapping, which is a prefix your API. And this is the unique identification of your API. You can see here that I've used get mapping because we are not going to modify the data. If I click on the get mapping, we can see here that the method is request method get, right? And this operation and API response are the metadata of your API. These are optional. Now you can see here the response type is response entity, and inside the response entity, I have added the list of user DTOs. Now, inside this method, you can see that I'm calling one method of a service class, which is returning the DTO, and I have added logic for the response. If user list is empty, then we are going to return the status code as a no content. If it is not empty, then along with the response entity, okay meaning is your HTTP status will be returned as a 200, which is successful. And along with that 200 status code, we are going to return the users list here. So you can see here that I haven't added any business logic here. I have only called up your service class method and everything is neat and clean here. Now let's go inside your service layer. You can see here that I created a user service interface because that could have been a multiple implementation of this user class. Let's go inside the implementation. You can see here that I've injected two dependencies here. One is repository, another one is user mapper. And again, I have used the constructor injection here. This is your method, which is getting called up from the controller. Inside that, you can see that it is calling your repository, your next layer. But the catch here is your repository is returning your entity, list of entities, and not the DTO. But as we spoke earlier, we must not pass on entities from one layer to another layer, right? Hence, we need a conversion. So for that, I'm using a user mapper here, which will help me to convert our entity into DTO. And after that, this will get passed on back to our controller. Let's go inside your user repository. Oh, it is empty. There is no method mentioned here at all. Then from where it is fetching find all method? You can see here that it is extending JPA repository. JPA is Java Persistent API. Okay, and you can see here that I have mentioned the entity class here, and you need to annotate this as a repository. So now when I click on JPA repository, you can see all the common methods which I use for the database operations are mentioned here. Your find all method is also mentioned here. Now let's look at another API. Here we are going to retrieve a specific user by their ID. You can see here that again I've used the get mapping This is the unique path for this API, which will get appended to the common path of API. And as per ID, there would be a single user DTO. Hence, we are going to send a single user DTO in our response entity. Now, before we hit our user service, we will add the validation logic for the input parameters. If the input parameters are either null or having a negative value, then we don't want extra overhead on our database calls. Now mind it here, we are not validating the data which we fetched from the database. Those kind of logic we has to put in our service layer. These are the validation data for the input parameters, and hence it is written inside controller. So now once we receive a user DTO from our user service, we will return it back to the client. If nothing is found, then we will send the HTTP status not found. And if the D2 is found, we will send it back with the status code 200. You can see that I'm using a path variable here. I could also use request parameter. There is a well-known interview question here is difference between path variable and request parameter. So this is how it looks. If you use a path variable, this is how your URL is going to look. And if you use request parameter, this is how your URL will look. So the major difference between path variable and request parameter is path variable extracts raw value from the path, no decoding. And request parameter automatically URL decodes the value. Let's go inside the service implementation of this method. Now here we can see that we are fetching the user entity based on the ID using JPA method find by ID. If entity is not found for this ID, then we are going to return the null object. And once the entity is found, we will check here using the ternary operator. If it is null, then we will return null. If it is not null, then we will send this entity to our mapper to convert this into DTO. And hence now this data will get returned into our DTO format. Let's look at another API. We are creating a new user here. You can see that I'm using a post mapping because we are going to modify the database table here. Inside this create method, you can see that I'm passing user DTO as a parameter and the type would be request body. And I'm going to write the logic inside try and catch so that if anything goes wrong, we can throw the exception and let the client know that something went wrong and user is not created. Now here I'm validating the input. If there is some issue with the input, then I'm going to return the bad request in response entity. If not, then I'm going to pass this DTO to the create method of service layer. And once the response received successfully, I'm going to pass request entity status created. Created is a 201 and not 200. 201 is the data, whatever the data has been passed in request has been created. So we need to be very particular with what we are returning, what HTTP status we are returning. Let's go inside our create method of service layer. In request, we are passing DTO. And if we want to dump this DTO into database, we have to get it converted into entity, right? So now again, we will use our user mapper to convert this DTO into entity. And now this DTO would be having all the data except few of the data which are only added into database. Like for example, created date, right? That we will add manually here. And once our user entity is ready, we will send it to a GPA repository save method. And this save method will manage insertion of this user entity. You don't need to write an explicit insert query to insert this data into database. This save method will take care of everything. It will insert the data into database and after that it will commit the session. So once it is done, it will return the inserted data. So now again, this is our entity. We need to convert into a DTO using our mapper. Now let's look at another API. We are going to update the user here. You can see that I'm using a put mapping here. Whenever you want to update the existing record, you use a put mapping. When you want to create a brand new record inside database, you use post mapping. Inside this update method, you can see that I'm passing two parameters. One is ID, another one is user DTO, the data of user which I want to replace. So here, first of all, I'll validate the ID. If anything goes wrong, then I'm going to return bad request. And then I'm going to validate the input DTO. If anything goes wrong here, then again, I'm going to send bad request here. If everything is good, then I'm going to pass both of these parameters to update method of service layer. And once I get the successful response back, I'll check if the response is null, then I'll return the response entity not found. And if this updated user DTO is not null, then I'll send response entity status as a 200. Now let's look at the update method of our service class. We can see here that user repository is calling the find by ID method, which is inbuilt method of our JPA repository. Based on the ID, it will fetch the user entity. If not found, then it will return null. If null found instead of a user entity, then we will return the null object. If user entity found for the given ID, then now we need to update this entity with these new values, right? And then only we will send it for the updation. So for that, again, our user mapper will help us. Let us go inside our user mapper. We can see here that inside our update entity from DTO method, we are manually updating the username from DTO to entity. So once our entity is updated with the new value, now we call the save method of user repository. This is again the inbuilt method of JPA repository. And after calling this method, your user entity will get updated with the new values. You can see here that again we don't have to explicitly write any update query for the user entity, and everything will get taken care inside this save method. So once the entity gets updated, it will commit and flush the data, and after that it will send updated entity data. And again, as we want to return it in the form of DTO, we will convert it using our user mapper. Last but not the least, delete user API. Here we are going to use delete mapping, and request parameter we are going to pass ID of a user which we want to delete. As you all know, first of all we will validate the ID. If anything is wrong with the ID, we are going to pass the bad request and response entity. If ID is good, then we are going to pass on this ID to find by ID method of service layer to check if the user exists or not. If user is not found, then we are going to send a not found message in response entity. If user is found, then we are going to pass this ID to delete method of service layer. And once this gets executed successfully, we are going to pass no content in a response entity, because the content which we supposed to pass has been already deleted from the database. So in many cases, the API developer is sending the content of a user. They are saving the user content in some temporary variable, and at the end they are sharing it to client that these details were exist earlier, but now those have been deleted. But the correct way is sending out a no content message along with the status that user has been deleted successfully. Let's check the service layer method to find by ID. This method we have already seen. So this will call the inbuilt method of JPA repository, and based on the ID, it will fetch the user entity. If not found, then it will return the null. And once we receive the user entity, we will get it converted into DTO. Once this has been found, our delete method of the service layer will get called up. Let's look at that. It is super simple. You will just call the delete by ID method. This is again the inbuilt method of a JPA repository, and pass the ID, and boom, it will delete the user entity from the database. And after the deletion, it will commit the data. Let's talk about database now. We are going to use H2. It is an in-memory database which is going to be local for your machine. Whenever you get your application up, H2 will get created, and as soon as you shut it down, H2 will get wiped out. For the configuration, you need to add these many lines in your application properties. TestDB is the name of your H2 database. org.h2.driver is your driver class name. SA is your username. We are not going to give any password here. I wanted to open the H2 console, hence I have given this URL explicitly. Now you can see I've added two SQL files in my class path. This will help me to get my H2 loaded. Schema.sql is having a DDL of my user table, and data.sql is having my DML for my H2 table. So that as soon as the application gets up, this data will be available inside my H2 database. So now our API is ready, our database is ready. Only one last thing is missing, that is visualization of our API. For that, we are going to use this dependency of OpenAPI. This will help us to see documentation of our API inside our Swagger UI. So for that, we need to do few of the configurations. These are the configuration you need to add in your application properties to get your Swagger UI enabled. So now we are ready. Finally, it's time to get our application up and running. For that, first of all, we are going to build the application and then run. So to build the application, we are going to use Maven commands clean and install. Basically, these are Maven's lifecycle commands. Clean command helps us to clean out the previous instance from the target directory, and install command executes all phases of the default lifecycle up to install. This includes validation, compilation, testing, packaging, and installation. Let me install this. Now we can see our build is successful. Now we will execute our run command, Maven Spring Boot run. Okay, so finally we can see here that my DOM case has been started and my application is also started. Now let us open our Swagger UI. This is how it looks. All of the API which we have created are visible here. Now let me try to fetch all the users from this API. Click on try it out, click on execute button, and you will see inside the response body all the records which are available in database are visible here. This is my request URL. You can see the prefix URL has been added and the unique part of the API also has been appended, and my CURL script is also mentioned here. Now let me run another API to fetch the user based on ID, execute, and I can see all the details of the user where the ID equal to 1. Now let me also open my H2 console so that we can see the data available in database. We can see the 2 records based on my data.sql script. Now if I try to delete one of the record from here, let me give ID 1. Now we can see the response as user deleted successfully. Let me run this query again. We can see there is only single record in this database now. ID equal to 1 record has been deleted. This was all about Spring Boot API. Thank you for watching till the end. If you enjoyed the video, please hit the like button. Subscribe my channel for more such contents. Thank you for watching. Bye bye.